students. Now we will discuss alternating current. Alternating current, the current whose magnitude changes sinusoidal with time is called alternating current. The direction of alternating current changes periodically. The magnitude of alternating current of angular frequency omega at any time t is given by I is equal to I naught sine omega t. Let it be equation number 1. Here I naught is the peak value of alternating current and angular frequency omega is given by omega is equal to 2 pi f or equal to 2 pi upon capital T. Put it equation number 2. Here small f is the frequency and capital T is the time period of alternating current. Graphically, the variation of alternating current with the time is shown in the figure. So this is the origin, this is x-axis and this is y-axis. Suppose we plot along x-axis time, variable time, and along y-axis variable is magnitude of alternating current. The graph will be as a sine curve as shown in the diagram. This is the peak value of alternating current and this is the peak value of alternating current in the opposite direction. So this is the definition of alternating current. This is half of the time period and this point is time period of alternating current. Now some definition. Mean value of alternating current. Mean value of alternating current is that value of steady current which send same amount of charge through a circuit as is sent by alternating current through same circuit in half time period. So this is origin and this is the x-axis and this is y-axis. Plot along x-axis as time variable and along the y-axis the variable is the magnitude of alternating current and current vary like this up to half time period. Suppose we divide the half time interval into n equal time interval, the one of which is this is dt is equal to t upon 2n. The interval each is equal to t upon 2n. Let half time period t by 2 is divided into n equal parts and I1, I2, I3 and so on, In be the current or you can say magnitude of current in first, second, third and so on up to nth interval respectively. Therefore, charge flow in half time period t by 2 is given by Q is equal to I1 into T upon 2N. This is charge flown in first interval plus I2 into T upon 2N. This is amount of charge flow in second time interval plus I3 into T by 2n. This is amount of charge flow in third time interval and so on up to In into T upon 2n, the amount of charge flow in nth time interval. The charge flow in each interval is not same as the magnitude of alternating current is not same, or Q is equal to I1 plus I2 plus I3 plus so on plus In into T upon 2n, that is taking T upon 2n common. Let this be equation number 1. Let Im be the mean value of alternating current over half time period. Therefore, then the charge sent by it in time t upon 2 mean half time interval is given by Q is equal to Im into t upon 2, as by definition the mean value of current will send same charge in same time t by 2 as is sent by alternating current in same time t by 2. Let it be equation number 2. From equation 1 and equation 2, we get Im into T upon 2 is equal to I1 plus I2 plus I3 plus so on plus In into T upon 2n. Now, in both the sides, capital T cancel each other, and also 2 and 2 cancel each other. So we get Im is equal to I1 plus I2 plus I3 plus so on plus In upon n. So this is the value of mean value of alternating current. Put it equation number 3. Right hand side is mean of the I1, I2, I3 and In. That's why it is called mean value of alternating current. By this formula, we cannot find the mean value of alternating current as values of I1, I2, I3 and so on In cannot be found. Mean value of alternating current for one time period is always 0, as charge sent by alternating current in first positive half is equal to charge sent by alternating current in second half in the opposite direction are same. So therefore, there is no net transfer of no net flow of charge by alternating current in one time period. That's why mean value of alternating current for one time period is always 0. Now other method to find mean value of current, that is by differentiation and integration. So this is origin and this is the x-axis and this is the y-axis. Along x-axis we plot time and along y-axis the variable is the magnitude of current I. The current, a alternating current, will change as shown in the diagram. Consider at any instant or at any time the time interval dt. This is dt time interval at any time t, and the value of current or mean value of current for this interval is I. I is supposed to be constant as dt is approaching 0, is very small time interval. This is half time period and this is one time period capital T. The magnitude of alternating current of angular frequency omega at any time t is given by I is equal to I naught sine omega t. Here I naught is the peak value of alternating current, and therefore the charge dq sent by alternating current in small time dt is given by, as shown in the diagram, this yellow area is equal to charge sent by AC in time interval dt, and is given by dt is equal to I into dt. Putting the value of I, we get dq is equal to I naught sine omega t into dt. Let it be equation number 4. To find total charge sent by AC in half time interval, half time period t by 2, integrate the equation for both sides. So we get integration of dq from 0 to capital Q is equal to integration from 0 to t by 2 of I naught sine omega t with respect to t, or Q integration of dq is Q and limit is 0 to capital Q is equal to, take I naught constant common, rest become integration from 0 to t by 2 of sine omega t with respect to t. Now integration of sine is minus cos, so this become equal to capital Q minus small q, mean first put upper limit minus then put lower limit. So capital Q minus small q become equal to I naught into cos omega t by omega, limit from 0 to t by 2. We have to divide by omega according to chain rule, or capital Q is equal to minus I naught upon omega into cos omega t by capital T by 2 cos of omega into capital T by 2 minus cos omega into 0. That is, first put upper limit minus then lower limit, or capital Q is equal to minus I naught upon omega into cos of 2 pi upon capital T, the value of omega into capital T by 2 minus cos of 0, as omega into 0 become 0. Now in first term, because omega is equal to 2 pi by capital T, and in first term 2 cancel with 2 and capital T cancel with capital T. So we get Q is equal to minus I naught upon omega into cos pi minus cos 0. Now put the value of cos 0 and cos pi. So capital Q become equal to minus I naught upon omega into minus 1 minus 1. The value of cos pi is minus 1 and value of cos 0 is 1. So it become minus 1 minus 1, it become minus 2, because cos 0 is equal to 1 and cos pi is equal to minus 1. So this is equal to minus I naught into capital T upon 2 pi, putting the value of omega into minus 2. Minus into minus become plus, so we get 2 and 2 cancel each other and minus into minus become plus. So we get capital Q is equal to I naught into capital T upon pi. Let it be equation number 5. Now let Im be the mean value of alternating current over half time period, then the charge sent by it in time capital T by 2 is given by capital Q is equal to Im into capital T upon 2. Let it be equation number 6. By definition, the charge Q must be same. From equation 5 and equation 6, we get Im into T by 2 is equal to I naught into capital T by pi. Now, from both the side, capital T cancel each other. So we get Im is equal to 2 I naught upon pi. Or putting the value of pi, it becomes nearly equal to 0.637 into I naught. So this is the value of mean value of current for half time interval. So we can find mean value of alternating current only for half time interval. As for full time interval, its value is 0, and also the value of mean value of alternating current changes with the time taken. So thank you very much.